Hi guys, so today we're going to be doing operations with polynomials. This too should be a review of what you've done in pre-algebra and algebra 1. Let's just get started. So the first one here, example 1, is degree of a polynomial. We're going to determine whether each expression is a polynomial first. And if it is a polynomial, we're going to state the degree of the polynomial. Okay. So here with A, yes, this is a polynomial. Okay. None of our variables are in square roots or radicals or anything. None of them are negative. Right? None of them are a fraction or anything. So yes, this is. Okay. And then to find the degree of the polynomial, it's going to be the term with the highest degree, whatever that one is, that's going to be the degree. So for example here, this is the first term, 1/6 x to the third y to the fifth. Okay. So looking at the variables and their powers, so x has a 3, y has a 5. So this first term has a degree of 8 because 3 plus 5 is 8. Okay. The second term here, this -9 to the x to the fourth, the variable here has a degree of 4. Okay, so we want the bigger one, so what would be the degree? 8 is bigger than 4, so it has a degree of 4. Degree of 8, because 8 is bigger. Okay, so B here, we have x plus square root of x plus 5. No, this is not a polynomial. Okay. Because x is in a radical or in a square root. It has a rational or a fraction as an exponent. Okay. C here, we have x to the negative second plus 3x to the negative first minus 4. This is no as well. Not a polynomial. Because x to the negative second will be 1 over x squared. Okay. And x to the negative first would be 1 over x to the first, right? And so here we have variables in the denominator. Okay, so why don't you try CYP 1A and 1B and then come check your answer when you're done. Okay, 1A you should have gotten not a polynomial. The reason why is because y here is in the denominator. For 1B, it is a polynomial and its degree is 7. The first term has a degree of 6, the second term has a degree of 7, and the third term has a degree of 2. So we want the term with the highest degree, and that's the middle one with a degree of 7. Okay, so next we're going to work on simplifying polynomials, and really all it is combining like terms when we're adding or subtracting. Okay, so here I have the quantity of 3x squared minus 2x plus 3 minus the quantity of x squared plus 4x minus 2. So the first polynomial I'm going to rewrite as the same, so 3x squared minus 2x plus 3. And then here, since I'm subtracting all of the second polynomial, since we're subtracting all of the second polynomial, I'm going to distribute this negative sign. Okay, so it's minus x squared. It's minusing 4x. And then minusing negative 2 is just adding 2. Okay. Then after that, we're just combining like terms. So starting with my highest degree or highest power. So 3x squared minus x squared becomes 2x squared. Negative 2x minus 4x is negative 6x. And then 3 plus 2 is 5. So our final answer is 2x squared minus 6x plus 5. Okay. With the next one here, we're adding. Adding is a little bit easier because we don't have to change signs. So when we're adding polynomials, all we're doing is we're just going to rewrite it without the parentheses. So adding a negative here is just negative. So negative 3x squared plus x minus 3. Okay, and then all I have to do is combine like terms. So 5x squared minus 3x squared is 2x squared. Negative 4x plus x is negative 3x, and 1 minus 3 is negative 2. So my final answer is 2x squared minus 3x minus 2. Okay. Remember, in order to be like terms, it has to be the same variable raised to the same power, which is why we don't combine these two, because even though they both have x's, they don't have the same power. Okay. And then if you have difficulty seeing what is like terms, one thing I suggest is highlighting ones that have the same degree and same power, because that helps a lot when it comes to simplifying. So that's a trick I kind of do sometimes when combining like terms or showing people how to combine like terms. You highlight ones that are like terms, and that makes it easier to see. Okay, so why don't you try CYP 2A and 2B, and once you're done, come check your answer. Okay, you should have gotten a negative 2x squared. Sorry, it kind of smeared a little when I highlighted minus 5x minus 1, and then the other one is 3x squared minus x minus 5. If you got it, you can move on to the next example. If not, here's your explanation. So 2a here, we're subtracting polynomials, so I need to remember that I distribute this negative sign to everything in the parentheses, which is why here it becomes a negative x squared, a minus 2x, and a minus 5. Then I combine like terms. Negative x squared minus x squared is negative 2x squared, negative 3x minus 2x is negative 5x, and 4 minus 5 is negative 1. For 2b here, since it's addition, it's a lot easier. I just remove the parentheses. Okay? And I combine like terms. So 3x squared is the only x squared. Negative x here is the only x to the power of 1. And then my only like terms here is negative 6 and 1, which gives me negative 5. Example 3 here is using the distributive property. Okay? And so what we do basically is we take what we're multiplying the polynomial with and we distribute. Okay? So here, 2x times 7x squared, so 2 times 7 is 14. So this becomes 14. And then x to the first power times x squared becomes x to the third because I add my exponents here. Okay. Then I'm going to do the next one. Okay. 2 times negative 3 is negative 6. And then x times x is x squared because it's 1 plus 1. Then here, distributing it to my last term, 2 times 5 is 10. So this becomes 10. It's nice and simple. Okay. So why don't you try CYP 3A and 3B and then see what you get. Okay, for 3A, you should have gotten 8x to the fourth plus 12x cubed minus 16x squared. And for 3B, you should have gotten 6a cubed plus 22a squared minus 40a. If you got that, you can move on to example 4. If not, here's your explanation. Okay, so here we're going to be distributing this 4/3 x squared. So here, you can also rewrite it here. So here you can see that I'm distributing 4/3 x squared times my 6x squared. The 4/3 x squared times my 9x, and my 4/3 x squared times my negative 12. Okay. Then, simplifying here, I'm going to multiply the coefficients together. So again, fractions are kind of division problems. So here you can think about it as 6 divided by 3 is 2. 2 times 4 is 8. Okay. X squared becomes x to the fourth because 2 plus 2 is 4. Okay. Then here, 9 divided by 3 is 3. 3 times 4 is 12. Okay. Then x squared times x to the first. 2 plus 1 is 3, so x cubed. Okay. And then here, negative 12 divided by 3 is negative 4. Negative 4 times 4 is negative 16, and then x squared is x squared. Okay. 3b here, negative 2 times negative 3 is 6. A times a squared, add our exponents, 1 plus 2 is 3, so a cubed. Okay. Negative 2 times negative 11 is positive 22. A times a is a squared because it's 1 and 1, so 1 plus 1 is 2. Okay. And then last, negative 2 times 20 is negative 40, so negative 40. So now here, we're going to do the same thing. We're going to distribute to each one. Right? So one thing you can do is you can rewrite it out. Right? So here I can write it as n squared times n plus n squared times 4. Right? And so here I distributed my n squared to the n and to the 4. Right? Then I can also do the same thing here. So 6n times n and 6n times 4. So here I'm distributing the 6n now to each of the terms in the next parentheses. Okay. And then I can do -2 and distribute it too. So -2, let's have somewhere, to n, and -2 times 4. And that takes care of me distributing my -2's. Right. Then I can just simplify it. So n squared times n is n cubed. N squared times 4 is 4n squared. 6n times n is 6n squared. 6n times 4 is 24, so 24n. -2 times n is -2n, and -2 times 4 is -8. Okay? And then now I'm just combining like terms. Right? So n cubed is the only cubed. 4n squared and 6n squared become 10n squares. 24n minus 2n, now there's only 22n, and then -8 here is my only constant. If you can do it in your head to get this, that's fine, right? But it's important to be able to write things like this and understand why it becomes this conceptually, because later when we're factoring by grouping and things like that, we're often going to be rewriting it like this, and it's important to see this step, because factoring is the reverse of multiplying. It's important that understanding when we're multiplying that it's this helps us that when we factor to go back to this. Okay? So why don't you try CYP4B, and once you're done, come check your answer. Okay, you should have gotten 2x squared. Oh, sorry. You should have gotten 6x cubed minus 14x squared plus 19x minus 5. If you got that right, you can get started on your homework. If not, here is your explanation. Okay. So first, I'm distributing 2x squared to everything in the parentheses, so that's why 2x squared times 3x and 2x squared times -1. Then I'm distributing the -4x to the parentheses, so -4x to 3x, and -4x times -1. And then last, I'm distributing my 5 to the parentheses, so that's why it's 5 times 3x and 5 times -1. 2x squared times 3x gives me 6x cubed. 2x squared times -1 gives me -2x squared. -4x times 3x is -12x squared. -4x times -1 is 4x. 5 times 3x is 15x, and 5 times -1 is -5. Okay? Combining like terms, 6x cubed stays as itself. -2x squared minus 12x squared gives me -14x squared. 4x plus 15x is 19x now, and -5. And there you go. That's it for today. Have a great rest of the day. Bye, guys.